Alright guys, this is Ashwin here. In this video we are going to see how to create a driver drowsiness detection system using OpenCV. We can also do it with an offline video, and with a change of a code you could also do it in real time, where you can extract the frames of the a video and do a real-time detection. So I'm going to use some formulas to detect whether the driver is drowsy or not. And in the same way, you could also use some deep learning model to see whether the eyes are closed or whether the person is yawning or not. So you can obviously do that, but it all depends on your project customization or requirements. But based on the testing, even this simple formula without doing any training of a model works better compared to the trained model, where you extract the eyes images and do the prediction from the trained model whether the eyes are closed or not. So let's dive into the video. First, you have to install some specific modules in order to this to work. Install modules. If you are running it in a local machine, that is especially Windows, means you have to install Visual C++, then CMake. You can download it using the internet and install it in your local machine. Install in local machine. Then we do pip install CMake to install for the Python version, and then for dlib you can download a wheel file and install it using that. So that will be pip install dlib. I already downloaded a dlib file, and it's present in my current folder. I can upload it. You can use it if you want. Currently I'm using Python 3.12. If the version is different, means you can download it from the internet. There is a GitHub repository where you can download this wheel file. It is better to use this wheel file, or else you will face some issues. And after this you can install face recognition. Pip install face recognition, and I think OpenCV will already be installed by installing all these things. So once all the installation completes, then we will import the modules. So let's import all the basic modules. Import OS, import OpenCV, import numpy as np, import pill, sorry, this is from pill, import image. Not sure whether pill is installed, have to check, and import matplot lib.pyplot as plot, import warnings dot filter warnings, and again I have to like zoom out to have this filter. Maybe I can increase the size in the settings. Okay, now this is better. I will ignore this, and we also need a facial recognition, and we have to find the distance between the facial points or the extracted points. So we will use Euclidean distance for that. First I will import face recognition, then I will import the distance function from scipy dot spatial, import distance as, I think distance would be fine. Run this. Okay, we have imported all the modules without any errors. Now we have to see how the extracted facial points will look like and highlight it in a test image. So what I will do is highlight facial points in the image. First I will have the image path. Image path equals test1.png, and you have to load the image. Image equals image dot open, and pass the image path. Then plot dot im show. You just display the image. If you don't want the axis, plot dot axis, it will be off. And this is how the image will look like if you plot it. So let's highlight the facial points here, including the mouth and eyes, nose, everything. So for that I will create a function. So def highlight facial points. I will pass the image path here. We will load the image. So image equals cv2.im read. As we will use cv2 to plot the points, it's better to use cv2 to load the image. Image path. Then you have to convert it to RGB. By default, the image will be in the format of BGR. So convert from BGR to RGB. So image RGB equals cv2 dot convert color of pass the image. So differentiate, I think we will say it as BGR. Sorry. Copy this and paste it here. Then cv2 dot color. See, there are so many colors are available. So color underscore BGR to RGB. Okay, now the images are converted. Let's detect the faces in the image. Detect faces in the image. Face locations. If the image has multiple faces, means you can detect all the faces using this function, which is the facial recognition dot face locations of image RGB, and you can specify the model equals CNN. So this will use a pre-trained CNN model to extract the facial locations. Then we will iterate each location of the face and plot it in the image. So for face location, in face locations, get facial landmarks equals face recognition dot face landmarks of image RGB, and then the face location. So this will highlight only the first face that we have and get only the landmarks. So I will use 0. After this, let's loop over the facial landmarks. Iterate over the facial landmarks and draw them on the image. Now for landmark type, landmark points in landmarks dot items, it's a dictionary. For x comma y in landmark points, this is the coordinates in the image. cv2 dot circle of image RGB, the coordinates which is x comma y. So now we have to specify the radius of the circle. I will specify it as 2 or 3 should be fine, and specify the color. So 0, 255 and 0. So this will have a green color points, and this is the thickness. I will specify it as -1, or we can specify it as 2, and see how the images are coming up. Based on it, you can change it however you like, and then plot the image. So plot dot figure, fig size, I will use 6,6. It's a square image. I will use IM show image RGB, and plot dot axis off, and finally plot dot show. I think here also, if you use plot dot show, it should display that. It should remove that additional text like this. Let's run this, and we already loaded the image, so I will just highlight facial points of image path. So if you are running it for the first time, it will try to download the model and load it, extract the facial locations, and after that it will do the plotting. But if you repeat the steps, it will be much faster. So here you can see the circles, and because we have specified the thickness, it's not like a full-fledged circle. So we will have it as -1. So now you can see we don't have those circles. Instead of that, we have the exact points, and all the facial points including nose and eyes are extracted. Using these points, we will calculate the distance and use the ratio to define a threshold for detecting the drowsiness for this person. I also have a video. I will go through it and will show you how to use that. To see how the points will look like, I also have a image with me, so I will load the image here. img source facial landmarks .png. If you run it, this is the facial landmark points. So this is the eyes points, and this is the points for the mouth. We will use both of them. We have to define a function for calculating the eye aspect ratio and mouth aspect ratio. Calculate eye aspect ratio. So def eye aspect ratio of, we will pass the eye points alone. We can use the landmark type to extract the eye points, and a equals distance dot Euclidean of eye of 1 and eye of 5. So the points starts from 0. So this is the starting point: 0, 1, 2, 3, 4, 5. So what I am doing is 0, 1. So first and fifth point I am taking the distance. So this will be A. And similarly, I will take the points for B, which will be 0, 1, 2, 2, 3, 4, 2 and 4. So this will be 2 and 4. And lastly, we have the C point, which is 0, 1, 2, 3, 0 and 3. So this point. So 2 points in the vertical manner we are taking, and horizontal manner we are taking a single point or single lines. So each starting and ending point are representing here. We are just taking a distance between them. Now here it will be 0 and 3. Now we will use the formula for EAR. AR, which is eye aspect ratio, A plus B divided by 2.0 multiplies by C. So this will give you the eye aspect ratio. And then we will get the aspect ratio for mouth. Calculate mouth aspect ratio. Mouth aspect ratio. If you don't want the mouth aspect ratio, you can leave it as well. Currently, I'm going to detect both eye closing and yawning. That's why I'm using both of them. Sorry, mouth. Here again we will have all the points. A equals distance dot Euclidean of mouth of empty and mouth of empty. So repeat the same steps 3 times. Change this to B and this will be C. In mouth we have many points. So we will go for the outer region 0, 1, 2, 3, 4, 5, 6. So 0 and 6 will be C. 0 and 6 will be C. For A, we will calculate this point 0, 1, 2. So this will be 2. 3, 4, 5, 6, 7, 8, 9, 10. So this will be 10. And in a similar way, 2, 3, 4. So this will be 4. And the corresponding point will be 8. So this is how you can calculate the mouth aspect ratio, which is MAR equals, you just paste the same formula here, and this will be MAR. Okay, that's it. Let's run this. So using this aspect ratio, we will process each frame or image. So we will create another function to detect the aspect ratio or thresholds to see whether the eyes are closed or mouth are opened for yawning. So def process image of, I will pass the frame from the video or the webcam. Define threshold. So eye aspect ratio thresh equals 0.25. If the eyes closing ratio is 0.25, you can use this. And for MAR thresh or mouth AR thresh equals 0.6. I'm using it here. And again, based on the experiments, based on the camera angle, you can change this accordingly. And then if frame is none, we will have an exception like raise, value error, images not found or unable to open. So these are some best practices you would do to see where the error is occurring. Then we will process the RGB frame. So RGB frame equals CV2 dot convert color of frame comma CV2 dot color underscore BGR to RGB. Okay. Then again you have to find all the facial locations. Find all face locations. So face locations equals face recognition dot face locations of the RGB frame. So this will extract all the faces. Then we will create some flags. Initiate flags. So eye flag equals mouth flag equals false. Initially, we will assume that the eyes are closed and the mouth, eyes are open and the mouth are closed, which is a normal state of a person. Then for face location, in face locations, extract facial landmarks. Landmarks equals, we will use again the same method which we used earlier. Face landmarks of RGB frame, comma, face location, and then 0. Then extract eye and mouth coordinates. Okay, here first we will take the left eye. Left eye equals np dot array of landmarks of left eye. Similarly, you can get it for the right eye. Right eye equals np dot array of landmarks of right eye. Then finally, we have to get it for the mouth. I'm not sure why I'm keep on typing mount, as it's like a mistake I'm constantly doing throughout the video. Bottom lip. Again, you can see the documentation of facial recognition if you want to extract any specific features from the face. This is like eyebrow, facial points alone, like that you can extract each individual point separately. Then calculate eye aspect ratio and mouth aspect ratio. So left eye aspect ratio equals eye aspect ratio of left eye, and right eye aspect ratio will be right eye, and we have to calculate the average. So I will say EAR equals left EAR plus right EAR divided by 2.0, because we have to calculate both the eyes, right? So if we take the average, we will get the approximate how much the both eyes are open. And for the mouth, we can just directly get it using the mouth aspect ratio. Pass the mouth coordinates and check if eyes are closed. Okay, here if EAR less than IAR thresh, then we will update the eye flag equals true. Now do the same, check if mouth, or check if yawning. So for that, if MAR is greater than MAR or mouth AR thresh, which is mouth flag equals true. I believe the steps are clear now. We are extracting the facial, we are converting the image to RGB, extract the face locations, get the facial landmark of that particular face, get left eye, right eye and the mouth coordinates, calculate the aspect ratio for each of them, check whether the eyes are closed, check whether the person is yawning, and finally you will return the flags, eye flag and mouth flag. Okay, now let's test it whether it's working or not. Let's read the image. img equals cv2 dot im read of the image path which we already have, and process image of image. Now you can see it's showing that eyes are closed and mouth is not open. So this gives us the results. So like this, you have to process each frame from the video. So here, real-time drowsiness detection. For now, I'm going to use a video path, but if you have a camera and you want to test it, means you can also do that. So test mp4 video capture equals cv2 dot video capture of 0. So this is for, we'll comment it here, for getting frames from the webcam. If you have multiple webcams, just choose the number accordingly. 0 means the default webcam. So this one I will comment it. If you want, you can always use that. And then for video cap, again cv2 dot video capture of the video path which we have. Then we will initialize count and score equals 0. So based on the scores, we will update whether the person is drowsy or not, because even if you just blink the eye, you can process the image and you can misinterpret that as drowsiness. But usually for drowsiness, you have to keep the eyes closed for a few seconds at least to have it like drowsiness. So that's why I'm keeping a count and a score. After it reaches some threshold, you will see that the person is drowsy, alert system. Now while true, success comma image equals video cap dot read, and if not success, that means if you reach the end, it will break. Then resize the image equals cv2 dot resize. Based on the aspect ratio of the image, resize it accordingly. For now, based on the input video, I am resizing to 800 cross 500, and this is completely customized based on the video you want to process. And if you increase this resolution, it will take some more time to process the image based on your hardware. Now count plus equals 1, and if count modulus 5 equals 0, process every 5th frame, or I will say it as n and make n as 5. Again, you don't have to process all the frames. In typical video, you will have 24 to 25 frames per second. So in a second, if you just take like 5 frames and process it, I think that would be enough. So this will be n. Depends on the frames, you can always adjust it. If you have like 60 frames per second, you can make this as 15 or 20. Then if count modulus 5 equals 0 means we will calculate both the eye flag and mouth flag equals process image of image. Then if eye flag or mouth flag, if any one of them is true, we will increment the score by 1. If any flag is true, increment the score, or else we will decrement the score by 1, and if score goes less than 0, we will just keep it as 0 to avoid the negative values. So this is the main processing. Now write the score value at bottom left of the image. Now how to specify the font? cv2 dot font font underscore Hershey simplex. Here it is. So after this you have the coordinates. So text x equals, I will have it as 10 for the x-axis, and for the y-axis, which is, I will use the image shape of 0 minus 10. Text equals f score, update the score here, and then cv2 dot put text, pass the image that we have, the text which we updated, coordinates text x and text y, then the font which we initialized, the font scale, color, we can have it in 0, 0 and 255, which will be in red, I guess, in BGR format. If you want, you can use any color coordinates you want. If you have like multiple values, it will produce a different color. We can check it, and this is the thickness of the text. Then the line type, line AA. So this will display the score at the bottom left. Then if score greater than or equal to 5, that means for 5 frames, if the eyes are closed or if the mouth is open, we will consider that as like the person is drowsy, and we will display the text as the person is drowsy. Okay, I think this we can have it as green itself. So for drowsiness, we will display it as red as an alert. Again, text x equals, we will use the image shape of 1 minus 130 to have some room for displaying the whole text drowsy. And text y equals image dot shape of, sorry, I think we can just use the direct coordinates, which is 40, and text equals drowsy. cv2 dot, I think we will use the same line, just I will change the color for differentiating, as this is a alert. So if it's in BGR, this is BGR, so I will have the red color. Then cv2 dot im show the frames, have it as have the title drowsiness detection, and then put the image. If you want to exit the video or processing by clicking on any key, you can set this exit if any key is pressed. If cv2 dot wait key of 1 and 0x ff not equals 255, then break. So this is just a masking parameter, so that any key is pressed, it will just do the mask, and if it's not equal to 255, it will just break. This is like a common practice in OpenCV. If you want to like have any key that is pressed, if you want to have like specific key, means you can also do that. And finally, we will release the video cap dot release, and we will destroy all the windows that was open. Destroy all windows. Okay, now that we have like created the full function, let's run this. So this is the video. You can see the score is increasing when the eyes are closed and showing drowsy, and again is closing and it's showing drowsy, and he is yawning and again closing, again it's getting drowsy. So for active state, the score is just going to resets after some time, like after each second. And if it's closing again, for if he's closing for a second, then we will display it as drowsy, because usually when eyes blink, it will be like a fraction of a second. So that's why we have those score that is present. If you want the score to increment after certain times, you can also do that here, like based on the frames that you are extracting. If you are extracting 1 frame per image, which is like 25, if you specify it here, you can just have the n will change and the score will change after only 1 second. Then if the score is just greater than 1, you can just display it as drowsy. So it all depends on the customization that you are doing. So make sure you do it based on your requirements. And that's pretty much it, guys. So in this video, we have seen how we used simple facial points to extract the frames from the video and processed it in real time. As you can see, the video was showing it in real time. If you have a camera, it will also show it in real time for you. You can test it and let me know in the comments and how it works. If you want, you can also use a machine learning model or a neural network to get these flags. You just have to like replace this line alone. That's it. Everything else remains the same for displaying it. And if you have any queries about this video, please leave a comment below. I will happy to help. Other than that, if you like this video, hit the like button, and thanks for watching this video.